Okay, question number 31. When the last video ended, we were in the midst of it. I had written it down but didn't have my calculator to switch the kilometers per hour to meters per second. So the first mass, the 1735 kilograms, is initially going 15.27 with the 7 repeating meters per second. The second guy is going 10.472 with the 2 repeating meters per second. Okay? So times, I could have done this while I was waiting for it to upload, but never thought of it, plus 1735 times equals, so the top is 53,106 divided by brackets 1735 plus 2540. Close the brackets, equals, so it should equal 12.42255 meters per second. Okay, and that will be in the direction of the original ones traveling north. Okay, but that's not all the question asks. So the question asks, if the cars stuck together after the collision and continued in a straight line, what was the combined momentum after the collision? So you want the momentum after the collision, so P final, and it'll be equal to m1 plus m2 times this velocity. So 1735 kilograms plus 2540 kilograms. And then you're going to multiply that by the 12.42255 meters per second. And the decimals here are going to depend on if you kept your repeating or if you rounded your repeating. So if your decimals are a little bit off, don't stress. It's just from rounding. So 1735 plus 2540 times our speed. You should get a final potential of 53106.38, and the 8 is repeating, kilogram meters per second north. Okay, so then the question says, was the collision elastic? So to find out if the collision is elastic, you have to go m1, 1/2 m1 v1 initial squared plus 1/2 m2 v2 initial squared is equal to 1/2, and afterwards they're stuck together, so again you could do m1 plus m2 because they're the only one object now, v final squared. So 1/2, m1 was the 1735 kilograms, v1 was 15.27 repeating meters per second, and that gets squared, plus 1/2 2540 kilograms times 10.472 with the 2 repeating meters per second squared equals 1/2 brackets 1735 plus 2540 times the velocity we just found, 12.42255 meters per second squared, equals 1735 plus 2540. All right, so you're going to square your 12.422, etc., multiply by 0.5, and then multiply by 1735 plus 2540. And so on this side, you get 329,858.3089 joules. And I did this side first because I had it in my calculator. Okay, so then 0.5 times 1735 times the speed 15 squared is I think I screwed something up. 1735 times 0.5 times, recall 1 squared. That's better. 2024 483.6034 joules is the first term, plus 0.5 times 2540 times the speed squared. Second term is 139,277.6466 joules. When you add these two together, you get 341,761.25 joules. And we're trying to figure out if that's equal to 329,858.3089 joules. Obviously, the first one is bigger. These are not equal. Put a line through it and write inelastic. And like I had said in class, when they're not equal, the initial should always be bigger than the final, because kinetic energy is always going to be lost if it's not conserved. It's never going to be gained. Okay? So there you are, your elastic questions. Hopefully you got them. You will see them again on the test next week. But for now, we are going to go to your sheet because I asked you to do numbers 10, 11, 12, and I think 13. All right, so number 10 says a 10 kilogram object moving north. So this is my 10 kilogram object, and this time I'm actually going to draw it, so it's moving north. 6 meters per second, so V1 initial is 6 meters per second. Collides with the 20 kilogram object moving south. So here's my 20 kilogram object, and it's moving south. V2 initial is 4 meters per second south, and this one was north. After the collision, the first object rebounds at 4 meters per second. So rebounds means goes in the opposite direction. So V1 final will be 4 meters per second, and now it's south. Calculate the velocity of the second object. So M1 V1 initial plus M2 V2 initial will equal M1 V1 final plus M2 V2 final. We're looking for V2 final, so take this term over. M1 V1 initial plus M2 V2 initial minus M1 V1 final equals M2 V2 final. To get V2 final alone, divide by M2. Okay? And now, be careful when you're filling your numbers in, because you got to look after the positives and negatives. So it was M1 V1 initial, M2 V2 initial minus M1 V1 final, all divided by M2. So V2 final is going to equal, M1 was 10 kilograms, and it's initially going north, so let's call north positive, 6 meters per second, plus 20 kilograms, and it's initially going south, so this will go in as negative 4 meters per second, minus the 10 kilogram object, which rebounds now and is going south, so negative 4 meters per second, and then divide by 20 kilograms, M2. So the first term is going to be 60 kilogram meters per second minus 80 kilogram meters per second, and then minus a minus, so plus 40 kilogram meters per second, and then divide it by 20 kilograms. So the top is going to be 20 kilogram meters per second. The bottom is going to be 20 kilograms. V2F is going to be 1 meter per second. And it's positive, so it'll be north, which should make sense, right? They're both traveling. One rebounds off the other should also probably rebound back. Okay, number 11. A red ball is moving east. So it's 2 kilograms, and we're going to run out of time on this one, and we'll have to come back to it. Moving east, so V red initial is 10 meters per second. It collides with a blue ball that is also traveling east, but with a speed of 4 meters per second. So V blue initial is 4 meters per second. Obviously, if they're both going in the same direction and the back one is faster, it's going to run into it. Because of the collision, the blue one speed increases, so V blue final